guys, welcome back to my channel. I'm Shams Fatima from Sri Venkateshwara College of Engineering, Bangalore. So today my topic is local replication technologies from the subject Storage Area Network with the code 18CS821. Now let's have a look. What is replication? Replica is an exact copy. Replication, the process of reproducing data. Local replication is replicating data within the same array or the same data center. So here we have a host followed by a replication and then a replica, that is the target, the exact copy. Now let's have a look at the possible uses of the local replicas. Alternate sources of the backup, an alternative to do backup on production volumes. Fast recovery, provide minimal RTO, recovery time objective. Decision support, use replicas to run decision support operations such as creating a report, reduce burden on production volumes. Testing platform, to test critical business data or the application. To test the critical business data or the application. Data migration. Use replicas to do data migration instead of production volumes. Now let's have a look at the consideration of the replicas. Types of the replica. Choice of the replica tie back into the RPO, recovery point objective. Point in time, PIT. Non-zero RPO, a continuous one. Near zero RPO. What makes a replica a good one? Recoverability and restartability. Replica should be able to restore data on the source devices. Restart businesses operations from the replica. Consistency. Ensuring the consistency is primary requirement for all replication technologies. Understanding the consistency. Ensure data buffered in the host is properly captured on the disk. When the replica is created, data is buffered in the host before written to the disk. Consistency is required to ensure the usability of the replica. Consistency can be achieved in the various ways. For file system, offline and the online. Unmount file system is for the offline process and the flush host buffers is for online file systems. For the databases, offline is the shutdown database, online is the database is hot backup mode. Dependent write input principle by holding the input outputs. File system consistency. Flushing host, it consists of application, file system, memory buffers, logical volume managers, and the physical disk drivers. It consists of source followed by the replica. Database consistency, dependent with the write input output principles. Dependent write, a write input output that will not be issued by an application until a proper related write input output has completed. A logical dependency, not a time dependency. Inherent in all databases management system, DBMS. Example, the page data write is dependent write input based on a successful log write. Necessary for the protection against a local outages, power failure, create a dependent write consistency images, a restart transforms the data dependent write consistency to translate the consistent. Committed transactions will be recovered in flight, transactions will be discarded. So here is the operation of data write input output. The source is created followed by a replica, and here the source is created followed by a replica. The first one is more consistent compared to the second one. Now let's have a look at the local replication technologies. Host based and the storage array based. The host based is logical volume manager based replication. and the file system snapshots. And the storage array based is the full volume mirroring, point based full volume replicas, followed by a pointer based virtual replication. So here is an example of the host based replication, LVM based replicas. So the host, a local volume followed by a physical volume 1 and a physical volume 2. LVM based replication limitations. So LVM based replicas add overhead on the host CPU. Each write is translated into two writes on the disk, can degrade the application performance if the host volumes are ready to store array LUNs, that is the local unit numbers, then added to the redundancy provided by the LVM mirroring is unnecessary. The devices will have same RAID protection already. Both replica and the sources are stored within the same volume groups. Replica cannot be accessed by another host. If the server fails, both sources and the replica would be unavailable. Now, let's have a look at the file system snapshots. Pointer-based replicas uses copy on the first write principle, uses bitmap and the block map. Bitmap is used to track the blocks that have changed on the production or the source's file system after the creation of snap initially all zeros. So the block map is used to indicate block addresses from the data to be read and the data to be accessed from the snap file system. Initially, the points of the production or the source's file systems requires a fraction of the space used by the original file system implemented by either the file system itself or by the LVM. Now let's have a look at the file system snapshot. How does it work? First, you need to read the snapshot file system, then consult the bitmap. If 0, then you can directly read to the production file system. If 1, then you can go to the block map, get the block address and the read data from that address. So here is the example for that. Now, the storage area based local replications. Replication performed by the array operating environment. Replicas are on the same array. Types of array-based replicas: full volume mirroring, pointer-based full volume replicas, pointer-based virtual replication. The first one is the production server, source replica array, and the BC server. Full volume mirroring attached. Target is fully physically copy of the source devices. Target is attached to the sources and the data from the source is copied to the target. Target is unavailable while it is attached. Target is a large as source devices, good for a full backup decision support. Good for the backup, decision support, development testing, and followed by the restore to the last PIT. The first one is the host, read write, source, followed by a target. If it is ready, then it is sent back to the host, else it is stayed in the target itself. So here is the attached full volume mirroring. Full volume mirroring detached. After synchronization, target can be detached from the sources and made available for the BC, that is business continuity operation. PIT is determined by the time of the detachment. After the detachment, resynchronization can be incremental. Only updated blocks are synchronized, modified blocks are detached. So here is a diagram which tells about the modified blocks which are being detached. So here is the host which gives the read and write operation, and here is the array followed by a target, and then the read and write operations are being sent to the host again. So this is the full volume mirroring source and target relationships. First one is source is equal to target. So attach synchronization. So second one, source is not equal to the target. So the detachment of the source relationship. Here source is not equal to the target. The third one is the resynchronization. Source is equal to the target. Pointer based full volume replication. Provide full copy of the sources of the data on the target. So the target devices is made accessible for the business operation as soon as the replication session is started. Point and time is determined by the time of the session activation. There are two modes: copy on the first axis, full copy mode. Target devices is at least as large as the sound devices. Full copy mode. On the session start, the entire content of the sources devices is copied to the target devices in the background. If the replication session is maintained or terminated, the target will contain all kind of original data from the sources at the PIT of the activation. Target can be used for the restore and the recovery. The target will only have the data that was accessed under the termination. Therefore, it can be used for resource and the recovery. Now let's talk about the restore and the restart operation. Source has a failure, logical corruption, physical failure of a source devices, failure of the production server, and the solution is restore data from the target to the store. The restore would typically be incremental. Application can be restarted even before synchronization is completed. Local replication management array-based. Replication management software residing on the storage array. It provides an interface for easy and reliable replication management. There are two types of interfaces, that is GLI and GUI. I hope you got some information from my video. If you like my video, please give it a thumbs up. Please do like, share and subscribe. Thanks for watching my video. See you guys in the next